Stats students, welcome to section 8.1b. More talk about hypothesis testing, and we're going to talk about type 1 and type 2 errors. So I know we're doing lots of bits and pieces here. We're going to put them all together for section 8.2. So bear with me as we kind of talk through things. So first of all, when we make decisions in hypothesis testing, the decisions are based on our sample data. So we're going to collect data and calculate X bar, and then we're going to make a decision about mu. So remember, we're always using our point estimate or our sample statistic to make a decision about our population parameter. We will reject H sub O if our evidence is strong enough. Remember, H sub O is our null hypothesis that is always a statement of equality. And we're going to not reject H sub O if our evidence is weak. It could happen by chance. So we don't think there is a difference. We think that they are equal. Remember that hypothesis testing does not prove our null hypothesis absolutely. Not sure why I have the word if in there. It's not absolute. The only way to be 100% confident is to use our population data. We don't have that. Our population, remember, is typically too big. So we want to collect a sample that represents our population and use that to see if our hypothesis or if our conjecture is on. So we talk about significance levels, definitely related to our confidence levels for confidence intervals. So significance level is looking at how large the difference between mu and X bar must be to reject or to not reject H sub O. So, and again, we can talk later in the chapter about how large the difference between P and P hat must be to reject or not reject H sub O. Whoops, I missed one. The significance level is the probability of making a type 1 error. We're going to talk about that in just a couple minutes. And the probability of type 1 error is a refresher. You know alpha already. Remember, alpha is 1 minus our confidence level. So when we make a confidence interval, we're 95% confident of something. But remember, there's that 5% that we are not 100% sure. It's our wiggle room. So that is our probability of making a type 1 error. Our most commonly used alphas are 0.10, 0.05, and 0.01. And just to throw in another term, we're going to talk about type 2 errors. Our probability of making a type 2 error is beta. So we're looking at those Greek letters. Remember, this is alpha, and beta is like a little b. So we'll talk about our type 1 and type 2 errors and what they mean in terms of rejecting or not rejecting our null hypothesis. So when we're talking about rejecting the null hypothesis, we always make the assumption that our null hypothesis is true unless we have significant evidence to reject it. That significant evidence, remember, is based on our sample data and our significance level. And in the real world, we could probably equate that to somebody is innocent until proven guilty. All right, so let's talk about that alpha and where it falls. We're going to mention critical values, but we're not going to use them. I want you to see what this looks like. You know I'm a visual person. So a critical value separates the critical or the rejection region. So notice this is labeled critical region. This is a rejection region. And this side as well. Notice we've got alpha on both sides, right? We've got that shaded region. So you need to make sure you notice that this is alpha over 2 because we've got an approximately normal distribution. It's symmetric, and we're looking at either end. If something falls in that non-shaded region, that's non-critical or non-rejection. So our researcher first has to choose our level of significance. Just like we talked about with confidence intervals, how confident do you want to be? Do I want to be 99% confident, 75% confident? The researcher chooses that, or the teacher. And when we're talking about our critical values, or we're talking about rejection regions, we're going to go to our ZT or our chi-square tables, just like we did for confidence intervals. So there's a lot of parallels going on here. We have two options then. I just showed you the picture with this alpha over 2. We also can have a one-tailed test. So notice my alpha isn't split between both ends of that normal distribution, because we only think that, if we're going back to last terminology, we only think for our H sub 1 that mu is greater than some value. Or down here, our H sub 1 would be mu is less than some value. So a one-tailed test can be right or left, depending on our depending on our alternative hypothesis. And here's the big one. This is a huge statement. Our H sub O should be rejected if our p-value is less than or equal to alpha. And we haven't mentioned that p-value yet, but that's going to come around as we put all of our bits and pieces together. We'll talk about that in section 8 too. So I also want to make sure I point out that this critical region is just alpha, because we didn't have to split it in half. So for our two-tailed, we have to split that in half. So one-tailed, we don't. So one more thing to keep track of. For example, suppose we've got a medical researcher choosing to be 99% confident. The alternative hypothesis is that the mean pulse rate is greater than 82 beats per minute, which means that our null hypothesis is that our mean heartbeat is equal to 82%. This one would be greater than, which means that it is right-tailed. So it looks like mu equals 82. And we think that perhaps it falls up here. So our alpha is going to be 1 minus 0.99 or 0.01. 0.01. And we don't split it because it's right-tailed. It's just one-tailed. The other example, exactly the same, right? Our alpha is still 0.01. We've still got our curve with the mu equals 82. For this one, our H sub O still, suppose the medical researcher chose an alternative hypothesis that the mean pulse rate is less than 82. So we know that it equals 82 for our H sub O. We know that it's less than 82 for our H sub 1, which means my alpha is down here, not divided by 2, because it's just left-tailed. So for our two-tailed test, same thing. When the research question is about whether the mean is different from a particular value, so you're going to see that word different or is not equal to, as in the case of alternative hypothesis, that the mean pulse rate is not equal to 82 beats per minute. That's all we've got. So we would say our H sub O, mu equals 82. They're not telling us what direction we're talking about, so our H sub 1 is just not equal to, which means if we've got ourselves our normal distribution with mu equals 82, we're not sure if it's less or greater, so we're going to go ahead and split that alpha into both ends and share it on both sides. So if we're talking about the same 99% confidence level, our alpha is still 0.01, but we've got to split that in half, so we've got a 0.005 for both ends. So it's important to recognize and to know if you're doing a one-tailed or a two-tailed test. All right, so now let's talk about these type 1 and type 2 errors. So we've got 4 possibilities of a statistical test, right? We can reject, we cannot reject. It really is true, it really is false. So kind of a fundamental counting rule here. So if we reject H sub O when it is true, that's bad, right? We said we don't like H sub O, but it's actually true. So if I look down here at my table, H sub O is true, but we rejected it. That is a bad decision, and that is also known as a type 1 error. I'm going to ask you to put this into context when we do problems. We'll do an example for it real quick after we talk about this. Let's see, our second possibility is that we reject H sub O when it's false. So we reject H sub O, but it is false, so that's a good decision. So I'm going to just put a happy face here. This is a correct decision. What about we do not reject H sub O, and it's true? So that's good. So we didn't reject it because we thought it was true, and it really is true. So that's an excellent decision. And what about if we do not reject H sub O, so we think it's good, but it's actually false? That's a bad decision, and that is a type 2 error. So to try to sum it up, type 1 and type 2. Type 1 is H sub O is true, but we rejected it. That's smart, right? Type 2, H sub O is not true, but we didn't reject it. So we kept it, but it's false. So let's talk about this in a big picture, not necessarily a statistical question, but let's talk about a murder trial. Person's on trial for murder. So first of all, I am going to put exactly the same table. H sub O is true, H sub O is false. I'm going to move this over. That's how we have it set up above. And over here, we reject H sub O, and we do not reject H sub O. But we're going to fill in what that actually means. So a person is on trial for murder, innocent until proven guilty, right? So H sub O is that they did not commit the murder, they are innocent. H sub 1 is that they did commit murder. They are not innocent. They did the crime. So if H sub O is true, that means that the person really is innocent. If H sub O is false, that means that they really are a killer. They're a murderer. So this is our decision over here. This is the jury goes out and makes a decision. The jury went out and they reject H sub O. They don't like H sub O, which means that the jury thinks that they are guilty. So I'm going to say they are found guilty. The jury went out and deliberated and they didn't reject H sub O, which means that they are found not guilty of the crime. So using context to talk about this. So let's think about this. What are the 2 good decisions that they made? They were found guilty and they're a killer, right? That's a good decision. They did the right thing. The other good decision is the person is innocent. They didn't kill anyone, and they were found not guilty. So the other 2 obviously are bad decisions, and we know what falls where. But what's happens, this one, the person is innocent and they were found guilty. That's a type 1 error, and that means an innocent person is going to prison, right? That's the context of it. Innocent, but prison time. The other one is that they are a killer, but they were found not guilty. That's a type 2 error, which means that a killer is set free. Which one's worse, do you think? That's a whole different discussion, right? All right, so that is it for section 8.1b. Again, lots of bits and pieces. Be patient. In section 8.2, we put it all together. Have a great